Hi, my name is Sergey Arisov, and I'm building digital environments for the deep tech startups. And today I'd like to record this lecture that I gave recently at Sheffield University for the PhDs and for everyone on the internet and for the ones who would like to participate at that point of time but haven't got a chance to. And This is a part of our collaboration between the Sheffield University and the Innovators Guild, which I am a part of. So we are trying to push the innovations forward within the UK, and we feel that the collaboration between all the innovators between the industries, is really important, especially when it comes to the new generation of innovators, the students. So feel free to join the Innovators Guild. I'm a mentor there, so if you'd like to see me as your mentor, please join the site and find me out there amongst the mentors. So first of all, who I am. So by the education, I'm the engineer, so I have rocket science degree on the bachelor and the master's. And the most important part of the rocket science is not the rockets themselves, which is quite fascinating, but actually the ability to work on the engineering level with the complicated systems in general. Because the principles are exactly the same, regardless whether you work within the rocket science, within the complicated PCB design, or you're working on the Formula One, for example, or creating the new generation of the robotics. So there is still a system design, system approach, validation, verification, complicated change management process, the certification approach, and so on and so on. So the most important skill that I've got is to engineer the complicated systems. But then I pretty fast and pretty quickly realized that actually I'd like to work on something else. So throughout my career, I worked with the different regulated programs, including nuclear and aerospace, and basically it all came to the scale and complexity. So it's the multiple migrations. I've throughout my career, I've run through the quite intensive training program, and I became a trainer myself. So all in all, I've educated around 600 engineers um, around the globe, and that was quite an interesting opportunity for me as a um, specialist and as a technical specialist at the very beginning, and then I've started to grow and basically ended up somewhere in between the business architecture and business analytics and project management roles. So all in all, maybe you can call it a product management, which is not quite the same. So also we've survived with my different teams. We've survived through the number of M&As, pretty complicated cultural context as well. So one of my projects had more than 25 different nationalities within the quite small startup, and the collaboration was quite intense, and the cultural context became a very big part of my everyday effort, everyday work. Um, Also, I've seen the startups grown from the very um, low level, like a small number of people, and quite intense hiring process was there as well. So that's uh, that's an interesting part. And also, I've got my pilot practices as well, and for the aviation industry in general, I'm feeling the product itself not only from the engineering perspective, not only from the IT perspective or the governance perspective, but also as an end customer. So when we talk about the complicated products, when we talk about the rockets, or in this case, I've chosen the aerospace, um, the most important part of all of it is to understand what is happening before your part of the job, before your part as a part of the step of the process, and where the data and what type of the data will be exactly consumed on the next step. So by whom it would be consumed, and for what reasons these people need the product of your effort. And that's why it is very important to understand the life cycle of the product that you're working on. Even if you're doing a very small part, this very small part might be either the bottleneck or just the important part of the process that will affect the next steps. And vice versa, if everyone else around you would know what you're doing, they will maybe prepare the documentation or prepare the data in a way that is a bit more digestible for you personally, so you can do your job easier and as a result faster. So here is the aircraft life cycle example. So as you can see, just on the high level, it's a quite complicated thing. So lots of steps, lots of iterations within those steps as well. Obviously, this is just a high-level process. We have a number of different activities within the different departments in order to certify a powertrain, certify an aircraft in general, and just go through all of those gates that we can see on this map as a green flags. So everything starting from the conceptual design, working on the preliminary design, going through the PDR, which is preliminary design review, then going down into the detailed design, which is still an engineering work, critical design review gate, then start working on the manufacturing and drawing on the prototype, because this is just the beginning. There is no certification yet, and we have only few prototypes, or maybe even one prototype, um, which we are working on. And at some point, we have a first flight rollout, and this is a time when we supposed to prove that whole chain that we worked on before that works quite tightly. And as you can see, the steps are quite tightly connected as well, and all of those iterations that are happening are quite often happening not just within the steps, but in between the steps as well. So next step is the manufacturing and the rollout of the proper manufacturing of a number of airplanes or the powertrains, and basically all comes to the maintenance and operations and proper production, and after all, we are ending the aircraft life cycle. So as you can see, lots of steps and lots of people involved, especially within the certification heavy industries like the aircraft. But my guess is that in nearest future, this certification demand will be higher, but at the same time, the amount of effort that will be required to certify such a products might be reduced dramatically. And that might be a part of my message for today. But what is this all about? So, in my opinion, result of engineering work is readable documentation of valuable hardware software that could be reproduced as many times as required. So basically, if you just have an R&D finished, you have a product, it doesn't mean that your work is covered. If there is no documentation that is connected to that product that allows any other people, at least within your standards, to reproduce this exact product in the same way and get the same results, your job isn't done. So I quite quickly noticed that for the engineer, his mm, main job is the art of finding the best solution possible. But instead, a lot of time is spent to reproduce the required documentation, to follow the rules, to get whatever it takes to fill in all the forms, papers, to get all those things done. And from my perspective, this is not the right thing to use this brilliant engineer's mind to fill in the papers, because especially nowadays, it wasn't like that 15 years ago when I started all of those things, but now it is quite obvious that the automation can give us much more free space and free time to invent, to build this art of, the engineering. And basically the motivation by which I started my education as an engineer. And yeah, so basically my aim is to give this freedom to the engineers and to help them maintain the traceability of the different artifacts being produced during the life cycle of the product, and at the same time feel free enough to build whatever it takes to fulfill all the requirements in the best possible way. So why the deep tech in general? So why we are talking about the deep tech in particular? Because there is a certain specifics within the deep tech that allows us to distinct it from all the, let's say, regular tech startups. So on the first picture, you can see a diagram which does exactly that. So basically the differences between the deep tech and the regular tech startup in a very simple form. We can take a look at the competition risks. Yes, the competition risk is much lower because of the other reasons. As you can see, there is a team risk which is higher. There is a capex intensity for the number of reasons that we are going to discuss a bit later on, and much higher development times. The market risk is also low, but the technology risk is quite high. And that's why the cycle within the deep tech startup, the cycle of development is quite different than the regular tech startups. Why it is important within the deep tech startup to think about the money. So as you can see, for the number of reasons, so the capex intensity, the reason for the capex intensity because the technology risk is there, and for a quite long time we are on the R&D cycle. So we are trying to produce a result. We are trying to create something which was never there. And that requires an additional effort, not only in time, but in specialists who are on average much more expensive. And obviously the labs, all the hardware, and sometimes the software as well. So for example, in my case, we had around 120 different pieces of the software on my last project, and that was quite intensive because we were working within the same company on the different directions for an R&D, and that required a big effort not only on the from the team side, but also to cover on the spendings for the software and the capex as well. So to buy all the hardware, to fill in the labs, to start the testing, to get in the results, to start the patternization of those results, and this research cycle might be quite long. But as you can see on the right side of the picture, is being covered by the government at the first place, and by the private sector as well. The next step, when we have a prototype, there is a certain first value of death. So because the banks are not interested so far, we are not that big, and at the same time, the venture capital is not that interested because we don't have a proper product, and this is where the money starts to be stretched, and the only thing that we can um, get this value through with is the angels. So it's a pretty rare people, pretty rare companies who are investing in such edge cases, and on average, they are former scientists on themselves and they understand the technology, or you need to spend a lot of time to explain your view, explain these technology and the risks under them. So this is the first value. That's why we need to all the time keep the money spending and budgets and flows in mind. Although ideally we're supposed to do the engineering job. Um, yeah, I'm still imagining that there is not many people in the company, so it's tens rather than hundreds. So everyone are doing everything at this point of time. And there is also a second value of death. So as you can see, for the deep tech startups in particular, it's a it's even harder for the number of reasons. So we have this scaling gap when we have the product and we start in the commercialization, but as we don't have many selling points, as the product itself is not something that you can see on average um, in the shop, in the grocery shop, for example, uh, it's quite hard to find a client. So that's why banks are not quite interested because you are not having enough revenue, and at the same time, um, the demand to build first few um, first few products is quite high from the financial standpoint. So this is another risk that you need to bear in mind. If you are going to work in the deep tech startup or you're going to found a deep tech startup. So what is happening now? What is happening now with all those technologies? So if you can see, um, nowadays we have two parts of the complicated technology. So first part is the software. So we have quite mature processes now, quite mature systems that helps us to support the application lifecycle. And those systems are also quite agile. And from my perspective, the software and software design and creating the new piece of software is something which is a stable process at the moment. The same happened with the hardware side. So the hardware was at some point, like the electronics, the PCB design was quite expensive. And now with a certain degree of globalization, um, it is has become more and more cheaper. And that's how those two pretty mature industries are coming together. So as I feel it, and as Gartner and a few other sources are stating, the integration between those two pieces, between the software and the hardware, all the industries where it comes together, like the robotics, like the um, drones, and with the implemented AI and complicated CNC machines and all those things all together, like self-driving cars, for example, are going to get more and more um, demand and basically a bigger market. So there is a standard curve of the hype cycle, but also it's a standard curve of the adoption cycle. So um, there is an emerging areas at the moment, so there is a certain amount of hype around the robotics at the moment, but at the same time, um, the technologies are maturing quite fast. So at some point, there is a new adoption is going to be something very, very normal in our life, and it's already becoming normal, like the self-driving cars, the drones which are delivering the packages by the air and by the roads. And obviously, we have a mature areas like the CNC machines, all kind of robots on the manufacturing facilities that are helping the people to make their lives a bit easier during the manufacturing process. And at the same time, on the right side, there is a certain estimation on the valuation upside for robotic startups. And I guess it's not only about the startups, right? It's about the um, about those domains as they are. So as you can see, there is a kind of 5-year cycle on the left side, but then it comes to 2050. So let me just move myself a bit like this. So as you can see, um, the market at the moment is already quite high. So the robotics and the drones and self-driving cars are there at around from 10 billion to 100 billion evaluation. But in the nearest 5 years, uh, it will be changed. So it will be much higher, and the self-driving cars and the drones technologies are quite mature already. And I guess they will be they will become a mature areas at some point. They will will be moved within this adoption curve to the right, and we will see them everywhere. So the same at some point will happen with the robotics in general, with the robots, with the um, humanoid robots, and that's what you can see on this right side of the picture, and the estimations are going in trillions. So when we work with those pretty complicated technologies, we ideally should consider a few things which are regulating the industry uh, by design. So we can estimate that as this as a like layers, like the basement and then the building, the stories of this building. But actually, from my perspective, this is all about the all basic things that we are supposed to consider as a kind of central piece of our universe, or this whole all of those layers supposed to be the basement for our building. So um, in each and every company, there are all those 5 directions, at least the ones which are dealing with the deep tech domain, and starting from the engineering assurance. Um, those are the aerospace standards in particular, but you are going to have your own if you're not the aerospace from the aerospace industry. Then there is a mm, IT operations and cybersecurity pieces. So it's ITIL standard and NIST standard by default. And those are the ones that you're supposed to consider when you are working on this kind of the products and this kind of environments. On top of it, we can build up the product lifecycle thing. So which will mean the traceability, change management process, and all things around it. And last but not least, the freshest ones is the AI governance part. So there is a NIST standard for the AI already. There is an ISO standard that estimates the risks for the risk register, the impact assessment, and the lifecycle control. So at this very moment, I guess that not all companies are dealing with the AI, but within the deep tech startups, it's quite an important piece because there is a lot of earthwork, as I mentioned, for the certification, for managing and governing the traceability that AI agents and AI in general can do now. So, which is a good opportunity to reduce the number of people that are bringing the effort towards this product significantly. And of course, the methodology. So, the most important part of this whole process is to understand what are we going to do in the next few steps. And that's how we are trying to build the strategy for as far as possible, but at the same time, the closer we are to the today's moment, the more detailed should be the plan. So that's why we have, for example, on average, 3 phases of the implementation, and let's break it down into the years, for example, which is quite convenient. So we have phase 1, year 1, phase 2, year 2, and phase 3, year 3. So obviously the phase 1, the year 1 would be the most detailed ones. And as you can see, the approach is quite clear and quite popular nowadays as well. So we are not inventing something new here. We're just using what we've got through the practice, and this is the whole iteration of the development cycle. And basically, after the first phase, ideally this first phase, if this is a year cycle, then we should break it at least in 4 smaller pieces, and maybe break it down in sub phases, um, which is which is quite convenient. So for example, in my case, I have the phase 1, which is document management system, and phase 2 is an internal AI system, and few next steps to be discussed. So I know at least what I'm going to do in the first 2 phases, and I also supposed to know what is the result, what will be the result of the whole project. So that's why we need, first of all, the prioritization. So we need to have something like a business process of the whole company, or how the value is being created within the company. So we need to follow that line. We need to speak to the people first to understand what is happening now. So what is the level of the visibility of the processes? What is the level of manual input? What is the um, what is a possible mistake that a person can make, and how we can avoid that. So basically, we need to understand the prioritization, knowing the pain points and the company priorities in general. So the next one is the senior buy-in. So within this dialogues, within this investigation, internal audit, we are supposed to speak with the seniors and understand their point of view. Sometimes, and quite often, those are contradictory points which we need to consider. And the more seniors buy-in we've got, the higher the chance of success of our program. Or if you, for example, just an engineer within the company, uh, the more people are involved in your initiative of implementing something new, the better. So the next step, as I mentioned, scope and phases. So understanding the strategy, understanding the prioritization, we are moving towards the phases and breaking down into these smaller pieces. And of course, we are not forgetting about the communication metrics. So we're supposed to deliver the results to the people who need it and the people who must be aware. And all those complicated matrices that we've used throughout my career um, sometimes overkill. So the communication matrix is just a very simple thing, but very effective. And then after each and every phase, we are demonstrating the results, aligning the uh, the feedback and aligning the next steps, because in the deep tech startups, you're inventing something new. So you never know what are the requirements in 100% of the cases. So sometimes you're trying to predict based on your experience. Sometimes you're just trying to compile different requirements from a different side, including the certification requirements or any other requirements that are uncommon, like requirements from the market, for example, or some compliance requirements as well. And you're creating the plan which helps you to move forward faster, adjusting the plan after each and every phase. And if you are on the project, if you are participating in the digital transformation project, if you are the CEO of the company and you are having the digital transformation initiative within your company, then you should know what are the examples that are flagging that something is wrong. And also, you should be aware of the first walls which are happening during the implementation. So as an example, I've chosen the AI implementation because that's a quite popular initiative. In my other videos in my course, I'm explaining why the implementation of AI is not always the best thing to do straight away, and what is Industry 5.0, what is the difference with the Industry 4.0, and sometimes in some companies are being on the level of the Industry 3.0, trying to implement the AI, thinking that it will help them, but unfortunately it's not always the case. So if you have or if you see those examples, please be aware that something might be wrong. So first of all, the garbage in, garbage out. It's a rule for everything, for all the digital transformation initiatives. So before executing the digital transformation project, please be aware what is the data you're working with. So what is the quality of this data? Because unfortunately, especially in R&D cycle, when you are um, executing a lot of iterations, when you work on a lot of things in parallel and trying and then checking and then going in the loop over and over again, it's not always um, the best timing to fill in all the papers to get leave the traceability, leave all the traces in place, and justify all the steps. So sometimes you don't have it, and before this initiative, the best option to do is to start from the quality of your data, from the basic visibility, from the basic traceability of what is happening. The next flag is no alignment between the teams and no buy-in from the seniors, which equals slow adoption. So if you see that there is a different aims or different understanding of the same project or the same initiative between the different departments or department heads, that is the risk. So you should either flag it if you are a technical specialist or an engineer on this kind of project, or if you're a CEO, you should start over, because this is something that we're supposed to start the projects. Third, more AI equals more data equals more entropy. So the generation of the documents has become quite cheap now, but the governance is has become more and more important because there's a lot of data now. You're supposed to control it. You're supposed to govern whatever you've designed. If there is a business process that you've designed with the help of AI, it's not always the right thing to implement it straight away as it is. So maybe there is some options for simplification, optimization before going to the implementation phase. And the next is no control of the data. In this case, equals more risk to expose proprietary data. So for example, if you're using like the free of charge options or personal accounts for the AI tools, we are putting the company under risk in terms of exposing the proprietary data. Because in most of the cases for the deep tech startups, you have a lot of R&D data, a lot of test data, and the process of getting the necessary documents for the patents are quite complicated and taking plenty of time. So that's why it is important to control the data. So that's why it is important to think about the NIST compliance all the time. And obviously, goals and phases are the secret. So if you have your goals, you have your phases, then you are much closer to success from the very beginning. The main question that should be there from the very start of the implementation of AI in particular, but it might be, as I mentioned, any digital transformation initiative, is how do we move from the ad hoc AI usage to controlled AI services that generate auditable business value? So this is the first wall, right? So when we are starting the AI implementation, we think that if we will just provide the access to all the people within the company, we first of all will get the control, we will get the instant results. But unfortunately, this is the first wall, which the majority companies who tried the AI are on at the moment. And what's important is not just provide the access, but also to train the people, because the awareness of AI on the high level is there, but how to use AI properly, how to ask him questions, how to ask it for a result, that's a good question that sometimes or often requires a training. So if you don't have a training, or if you haven't created a training for your team, just think about it. It might be a very good starting point. And from my perspective, even when we are implementing the AI, which is by the definition something which is supposed to do the job for us, there is a still 60% of the work within people and between people to align, to get the buy-in, to um, solve the conflicts which are there between the teams. Another 30% goes to visibility and control. So the very basic things that you're supposed to start from after everyone are aligned, where are we going and what we are doing. We're supposed to have the connection between the pieces and the control of it. And in this case, only 10% is AI implementation. And from my perspective, it works not only with AI implementation, but also within the all digital transformation projects. So this is what we got as a result of the experience. And during the R&D cycle, during the first phase of the maturity of the product, there is a number of common pain points that you might like to pay attention at first place. So first thing is the data lake for the test data. It's not only about the not only about the HDDs and infrastructure, It is also about the organizing of how this data would be stored and what is the policy for storing of this data, but also um, the accessibility of this data and the control of that accessibility. Then lots of branches and iterations, which is leading towards the lots of generation of many artifacts during the process, which is also a big thing to control. So lots of iteration means lots of revisions of the same documents, means lots of change management processes, which are supposed to be light enough to survive the R&D cycle, because we always think about the money, right? Next is the design of experiments for multiple factors. So the complexity of the experiments, complexity of the tests is quite high. So as we can see, there's a multiple factors. So when we are thinking about, okay, what is the next experiment? So what should we push through, and what should we push, and what parameters should we change? For example, we have at least like 12 parameters in different sectors, uh, which we trying to think about, and how it will, how the change of one factor will affect on the others, and that's why it is important to free as much mental space within the minds of the engineers for thinking about the solution and not the fixing the forms and fitting the forms. Then the constant changes of requirements, specifications, and the bill of materials, which is also a big thing. So that's why the system is supposed to be light enough. And nowadays, the majority of the enterprise environments are quite heavy on those things. That's why the R&D processes are quite complicated and or leaving no trace. That's why you need to keep the balance between the control and the freedom. And those things are the very basic things. So requirements and bill of materials um, are must have for, as you can see on the right side, all of those gates. So on the first column we have a number of documents, and on the right side we have a different gates that we're supposed to survive through within the different statuses of those documents. And those documents are changing on top of the specification of the requirements and bill of material. And of course, we're not forgetting about the quite complicated supply chain, especially um, last few years after COVID times, and all those changes on the go are supposed to be controlled. So all those domains, the documents, the requirement specification, the bill of material, 3D model, and collaboration with the suppliers supposed to be controlled. And as I mentioned before, and many times, we also always think about the budget constraints, because the outsourcing or making in-house is a question of the time/money uh, balance. So this is something to think about as well as an engineer, as a digital transformation specialist, or as a CEO of the company. So this was a high-level overview of my opinion, my work, and my experience. And please feel free to subscribe, and feel free to find me on LinkedIn and watch my other videos. I'm reading all the comments. So if you think that this was useful, if you have any other questions on top of what I've tried to deliver to you today, feel free to leave it in the comments.
Digital transformation time. Digital transformation time.